assessment asks us to predict the product of replacing each of these hydrogens with a deuterium, and then determine if the original structure of these hydrogens would be represented by one signal or by two signals. If we replace hydrogen A with a deuterium, we would end up with the same carbon skeleton, but hydrogen A would be replaced with the deuterium on a dash, whereas hydrogen B would remain on a wedge. If we do the same thing for the other structure, we again would end up with the same carbon skeleton, but on a wedge this time would be the deuterium replacing hydrogen B, whereas hydrogen A would remain on a dash. These are the products that would result from replacing each of these hydrogens. Deuterium and hydrogen are isotopes, but they are different from each other, so these molecules now have a stereocenter. The stereocenter has changed configuration between the two molecules, and so these molecules are enantiomers of each other, which means these hydrogens in the original structure are enantiotopic hydrogens. They're not diastereotopic, they're enantiotopic. And enantiotopic hydrogens feel the same chemical shift, feel the same magnetic field strength around them, and so they are therefore represented by the same one signal. These two hydrogens would be represented by the same signal in proton NMR.